Hello again, everyone. This video will give you a quick review of 30, 60, 90 triangles and how to work with them. Again, to review from geometry, we get the 30, 60, 90 ratios from an equilateral triangle. Just to make it easy for ourselves, let's make it an equilateral triangle where all of the sides are a length of 2. I'm going to drop a perpendicular down right here. And so we know, since all of the angles of the equilateral triangle measure 60 degrees, when we drop that perpendicular, both of these are going to be 30. And so here's our 30, 60, 90 triangles. This bottom side here will be bisected. So both of these halves of the triangle will have a length of 1. And so using this right triangle right here, I just Pythagorean theorem this bad boy. Make sure that we're careful when we set this up because we're missing a leg. So A or B is to be one of the variables. C, the hypotenuse, is a length of 2. Do a little bit of algebra, and after we do that, we see that height, or in other words, the leg of the triangle that's opposite the 60 degrees, has a length of square root of 3. Therefore, any 30, 60, 90 triangle has this ratio. The hypotenuse is always twice the length of the leg that's opposite the 30-degree angle, and the leg opposite the 60-degree angle is always square root of 3 times the leg that's opposite the 30-degree angle. Like I said before, if you can't just pull it off the top of your head, a visual might be helpful when you have to work with these. So this first one here, we're given the angle opposite the 30 degrees. So this is the simplest one of these to do. All we just fill in is 9 square root of 3 goes opposite the 60 degree angle. And then double 9, that's 18. That goes for the length of the hypotenuse, and you're done. Two other pretty nice ones. Notice number 2, I already have the square root of 3 opposite the 60. So just divide by the square root of 3 to get the leg opposite the 30. That's just 10. And then the hypotenuse is just double that, which is going to be 20. Same with 3. I'm given the hypotenuse. I just have to cut the hypotenuse in half to get the side opposite the 30-degree angle. So that's 25 halves. And then opposite the 60-degree angle is just 25 halves square root of 3. That's easy, Mr. Paws. Make it harder. Oh, okay. Hopefully, though, if you watch the previous video I did about 45, 45, 90 triangles, hopefully you'll be able to notice that you'll be able to use some of the same relationships. And that's why it's important when you're practicing these, always just keep doing them over and over and over, so those relationships you see just start to become really natural. And it saves you a lot of time, too. So here's my 30, 60, 90 triangle here for number 4. And it's really tempting to just fill out the 1 and the 2 and be like, yay, I did it, but that would be totally wrong. So again, we got to notice that the square root of 3 is the side opposite the 30. So it's actually pretty easy because that's what we want first. It's always easiest to find the length of the side opposite the 30, but we just got to realize when I find the side opposite the 60, I got to multiply the square root of 3 times the square root of 3, which will just be the square root of 9 or in other words, just 3. And the hypotenuse isn't bad at all, since it's just 2 times the 30 side. We just do 2 times the square root of 3, and that one's that. Again, not super complicated, but you just gotta pay attention and make sure you avoid tricking yourself. Similar thing in number 5. Notice though now the 33 is opposite the 60, so instead of multiplying by the square root of 3, I'm going to need to divide. And again, get in the habit of rationalizing the denominators, because 33 over the square root of 3 will very rarely, if ever, be a multiple choice answer. So multiply both the numerator and denominator by square root of 3. We get 33 square root of 3 divided by 3. And 33 thirds is much more easily stated as 11. So opposite the 30-degree angle, we have 11 square root of 3. And then I just have to double that to get the hypotenuse. And the hypotenuse will just be 22 square root of 3. Again, notice these relationships. They're very similar to the square root of 2 ones in the 45, 45, 90 triangles. When I have the square root of 3 opposite the 30-degree angle, like in number 4, the coefficient just ends up getting multiplied by 3. And in number 5, when I have no radical 3 opposite the 60-degree angle, to get the side opposite the 30-degree angle, I just divide, and notice that the coefficient, 11 square root of 3, is just 33 divided by 3. So again, practice these enough, practice, and you'll get those shortcuts into your head that'll save you a lot of time.